Hi, I'm George Uetz. For those of you who know me, you realize that I'm talking about a subject other than wolf spider communication. For those of you who don't, my career has been schizophrenic in the sense that I've worked on colonial orb-weaving spiders in Mexico as well as wolf spiders in Ohio. Nonetheless, this is a report on colonial web-building spiders in California. Now, many are familiar, surely, with El Nino, this weather phenomenon that occurs every few years. It's often called the Southern Oscillation, but the, um, the El Nino is a consequence of changes in equatorial Pacific sea surface temperatures. And every several years, it results in a mass of warm water sending up um, moisture into the atmosphere, which affects the west coast of North and South America, and then alternates with another pattern called an La Nina, which is a drying spell on those same general areas. But these alternating wet and dry periods are very important because they have large-scale ecological effects. As I said, I studied colonial spiders in Mexico for a long time, and my colleagues Craig Heber and Gary Polis and I recognized that during El Nino years there was a change in the social behavior of these spiders. They tended to be more likely found in groups than in non-El Nino years. This Gary discovered was a consequence of bottom-up trophic cascades, which tend to the increased rainfall enriches the vegetation, increases the number of insect prey, and spider numbers follow. I had been visiting the coast of California for professional meetings of my wife for many years, and I noted that there were a lot of Metepeira spinipes around in the coastal scrub. But in the 1998 meeting of the International Society of Behavioral Ecology, I noticed there had been a dramatic change, realized that this followed the 97-98 El Nino. And this consequently began this long-term study that I'm talking to you about today. We chose several study sites on the California coast to see if this was a phenomenon that was the same in all areas. To the north, or I should say the south of San Francisco Bay and the north of Monterey Bay, Half Moon Bay, famous for its surfing spot mavericks, and Año Nuevo State Reserve, famous for its elephant seals, are the northern study sites. They're a pair of mesic and dry habitats. Same is true to the south of Monterey Bay towards the Big Sur. Silomar State Beach is the mesic site, and Point Lobos is higher and drier. And we conducted at these sites annual censuses and other studies over a 20-year period. As you can see from the census data here, in both the Monterey Peninsula and the Half Moon Bay area, there is a consistent pattern of rise and fall of populations, both the number of colonies and the mean colony size that is associated with the alternation of El Nino and La Nina periods. After an El Nino, there's an increase in both colonies and colony size during the La Nina years in both sets of sites, and then ultimately, as La Nina goes on, a decline in the numbers. The structure of colonies, based on their size distribution, is analyzed with a zero truncated Poisson distribution. And what you can see in these two graphs is that both Monterey Peninsula and Half Moon Bay have pretty much the same structure of colony size distribution, but they differ between mesic and dry sites. Mesic sites tend to have larger colonies, greater sized colonies than in the dry sites, while the dry sites tend to have more solitaries. This has persisted over all 20 years of the study. We believe this cycle is a consequence of spiders following the prediction of risk sensitivity theory. This theory predicts that spiders will aggregate in prey-rich areas, which is a risk-averse strategy, and clearly they do. The intermediate and large colonies have a much higher rate of prey interception at the colony and web level. They also have a much higher rate of individual prey capture. And individuals in larger groups obtain more prey. At the same time, in larger groups, prey capture variance at the individual level decreases. And this is what risk-averse spiders are seeking to take advantage of by joining groups. There's a benefit, fitness, in terms of aggregation because spiders and colonies have more egg sacs than solitaries do, and their reproductive success is greater. But interestingly, this reveals a possibility of how this cycle is driven because given the number of egg sacs present in the fall and winter of one year and the census of the number of spiders the following summer, realize that the more spiders and the more egg sacs, the more spiders the following summer may be driving the pattern. So in conclusion, El Nino has a strong ecosystem level influence on the California coast with increased rainfall in El Nino years and bottom-up pulses of prey availability in El Nino years. As a consequence, aggregations form in areas of high prey density because of risk sensitivity. Individuals in larger groups have higher reproductive success, and consequently, the increase in La Nina years that follow El Nino years is a result of that prey resource moving up the food chain. I'd like to thank my collaborators on the study, Andy Roberts, Janai Rutledge, Mark T. Meyer, and Darius Prigoda, and also thank my wife, Kitty, who's a fantastic field assistant all these years. The California Department of Parks and Recreation, the NSF Small Grant Exploratory Research Program, and the University of Cincinnati have all been supportive. And I also want to acknowledge the native peoples upon whose land this research was conducted, the Ohlone, the Rumsen, the Muwekma, and the Ramaytush. And I hope I'm saying those names right. If you have any questions, I'll be happy to answer them. If you're seeing this as a recording, send your questions to me at the email address below. Thank you very much.